In this presentation, we're going to look at inference procedures, and what we're going to look at is the difference in means between two populations. So we have two populations, and we're going to take a sample of each population, and we're going to calculate the mean of both samples and compare them. And from that comparison, what we're going to do is make some inferences about the two populations that they come from. So a pharmaceutical company wants to test Dozanol, a new cold medicine intended for night use. Tests for such products often include a treatment group of people who use the drug and a control group of people who do not use the drug. So those are our two groups essentially. Those are our two populations: people who use the drug and people who will not use the drug when they're suffering from colds. Okay. 50 people with colds are given Dozanol and 100 were not. Okay, so the systolic blood pressure is measured for both subjects, both sets of subjects, and the sample statistics are taken below. So essentially what we want to do is see if the drugs have any effect on blood pressure. Okay, now if you're familiar with medical statistics and think these numbers look a bit funny, they probably are. They were just made up just to make as easy procedure. Okay, hypothesis test procedure. Okay, now just a sort of quick remark, it's not something I'm going to look at too much in this video, but it is sort of well worth stating that we're going to make a quick assumption about the equality of the variances there. So just a sort of quick statement to say that S1, assume sigma 1 squared equals sigma 2 squared. Okay, now it's a required assumption for proceeding as we're about to proceed there. Okay, just a sort of quick statement like that would usually be helpful. Okay, and okay, basically because those numbers are fairly similar to each other. Okay, now so we have two groups. The mean and standard deviation for the first group is 203.4 and 39.4. And the mean and standard deviation for the second group, the control group, is 189.4 and 39. Okay, so using a 5% significance level, test the claim that the Dozanol does not affect blood pressure. Clearly state your null and alternative hypotheses and your conclusion. Just as a quick remark, actually, there was a question. There's a part of this that was commented at that deals with stuff like this in more detail. So I'm going to sort of skip past that, but just remark that there was a different more to this here where I would talk about that assumption there. So I'm just going to sort of move past that. So we have a 4-step procedure for carrying out hypothesis tests, and that's it there. So I'm just going to use these 4 steps and as a sort of route through this question. So if you want to have a quick read of it, you can pause the video there and have a quick read of it, but I'm going to move on. So first off, a statement of a hypothesis, and so just essentially what we have to do here is make a quick statement there about the null hypothesis. H0 proposes that the medication is not effective. It makes no difference in terms of blood pressure. Sorry, doesn't affect blood pressure. That's not the same thing. It is, we're looking at, does affect blood pressure. I just slightly rephrase that. Okay. So it does make a difference in terms of blood pressure or lack of blood pressure. I've just forgot it's about cold. It's not a blood pressure medication. Okay. So it does not affect blood pressure and it does affect blood pressure. Okay. So mu1 equals mu2, mu1 not equal to mu2. The populations are mean. The population means are equal to each other, which is to say no effect or doesn't cause it to go up or down. And the second one is that they are different from each other, and the one is, there is an effect on blood pressure there. Now, just as a quick remark, does not affect blood pressure. Okay, it doesn't increase blood pressure. It doesn't decrease blood pressure. That's not what we're asked. We're not asked if it increases or decreases anything. We just want to see if it affects it. So that's important here when we read our question, because it sort of essentially sort of begets this about a two-tailed test. Okay, so it's equals versus not equals. Okay, does not affect. Okay, so that is relevant because usually a you have to read the questions very carefully because in case it is a two-tailed test. So I'll just write that there. It's a two-tailed procedure. Now, I'm just going to restate the hypotheses here in terms of difference in means, actually. Okay, so what this up here we have up here is mathematically equivalent to that there. It's just stated in a slightly different way. Okay. So the point estimate is essentially the difference in means. So we're on to our second step, calculate the test statistic. So the point estimate is essentially the difference in means. It is 14, whatever the measurement is, units are. So the standard error is typically given in the back of the exam paper, and it's based on the sample sizes and of the both groups and the sample variances of both groups, which is to say the standard deviation squared. Now it's a bit of calculator work ahead of you there. 39.4 squared divided by 50 plus 30.0 squared divided by 100. Okay, and that gives us 1552.36 divided by 50 plus 1521 divided by 100. That works out to be the square root of 31.04 plus 15.21. So let's say that is square root of 46.25, 26 if you want. You should get a value there close to 6.8. Okay. Now, I go into a lot of decimal places in the videos just to make it easier for you to sort of see how close you are to me. Okay, but you don't have to do that really. So that's the standard error, but we have to calculate the test statistic here. The test statistic is TS, is a normally distributed random variable, and you just make a quick statement like that. Okay, just to sort of explain what your notation is, or what a TS means. Okay, just to have a bit of clarity about that. So this is the general structure for a test statistic. It is the point estimate minus the expected value under the null hypothesis. Okay, here that is, we expect a difference of 0. Okay, on the null hypothesis there's no difference, so the difference equals 0. We observed from our samples a difference of 14 in the difference of means, and our standard error there is 6.8. So altogether our test statistic there is 2.05. You can just state it to two decimal places if you want, 2.06. Now, there's a lot of work here in terms of calculating critical values, and I'm not going to get into it into a great detail. There are a couple of key considerations. First off, we're dealing with a large sample. Okay, the aggregate sample size is greater than 30. It's a two-tailed procedure. Okay, we're told that the significance level is 5%, which would be fairly common in undergraduate statistics courses. So hopefully that would be pointing you towards the conclusion that the critical value there is 1.96. Okay, so if not, you're probably gone a little bit too far there in terms of watching this video. There's stuff about critical values that you probably need to learn about first. Okay, so you could go back to those. Now, our conclusions: we either reject the null hypothesis or we fail to reject the null hypothesis. And these are essentially statements about the strength of evidence we have. They are not really statements about proof. Okay, you don't prove anything with a hypothesis test. You just really make a statement about the strength of the evidence, so that you might go on and carry out more hypothesis tests. Okay, so so it's essentially a statement about the strength of evidence. Okay, so you could say that the test statistic is a measure of the strength of evidence, and the critical value is a threshold that it has to be greater than to be considered strong enough. Okay, that's a bit of a layman's terms, not exactly perfectly mathematically sound way of describing it, but it certainly helps you if you're getting used to this stuff for the first time. So actually I should put in the absolute value of the test statistic there. Is the absolute value of the test statistic greater than the critical value? Here it is. In that case, we reject the null hypothesis. That is what we would do in this case. Otherwise, we would fail to reject the null hypothesis. Okay, but this is the situation we have here. The absolute value is greater than the test statistic. So here didn't mean to do that. Here 2.06 is greater than 1.96, so we can reject the null hypothesis. Enough evidence of a significant difference. So it does affect blood pressure. Actually, I'm just breaking my own rule. Evidence to support hypothesis, if you want. Evidence to support theory. Let's not use the word hypothesis there, it just gets confused. Support the theory that dosanol does affect blood pressure. Okay? Bit of a scribbly way of concluding that, but you should make a conclusion like that, just in terms of the question, and just actually frame your conclusion in terms of evidence, and does it support the theory, does it not support the theory. Just a quick bit of wording there just to help you state that you understand what's going on. And again, actually, just to sort of make sure that you sort of frame it in terms of evidence and not proof, okay? Which is why I added in that extra bit of text there. Okay, that's good. We'll leave that there.